This is solutions video number 2. At the end of this video, you should be able to describe the colligative properties of a solution. To do this video, you should have solutions video number 2 worksheet and a pencil. Colligative properties are properties that depend on the concentration of the solute particles, but do not depend on the identity. In other words, we do not care what is the type of solute we have, what is it, sodium chloride, is it sugar. All we care about is the concentration of the particles that it makes when it goes into the solution. There are 4 main types of colligative properties: vapor pressure depression, freezing point depression, boiling point elevation, and osmotic pressure. We're going to be focusing on the first 3 in chemistry class. Osmotic pressure is what they discussed during biology class. Why is the vapor pressure of a solution less than the pure solvent? So we are saying that here we have the solvent, pure solvent, and we're going to say his vapor pressure is greater than what it is for the solution. The solution has to be a mixture of more than one thing. So we're seeing the solute particles and the solvent. And in this case, the vapor pressure is going to be less. The reason why: if you have a pure solvent, you're going to have a rate of vaporization that is greater than what is occurring over here. Now, at any temperature, there's going to be an equilibrium that exists between the vaporization and the condensation. This equilibrium is going to occur at a faster rate, and so there's going to be more gas particles above the solvent, therefore a greater vapor pressure. In the solution, this rate of evaporation is going to be less than what it was when it was pure, and the condensation rate will occur to create an equilibrium. This equilibrium will be at a slower rate than what you had when it was pure. The reason is the solvent particles in the solution are attracting the solvent, making it harder to evaporate and the equilibrium to be less. So what are we going to say? If you have a pure solvent, the molecules escape at a faster rate than they do in a solution. As a result, vapor pressure is higher for the solvent, or vapor pressure is less for the solution. Why is the boiling point of a solution going to be higher than the boiling point of a pure compound? One thing to keep in mind: when you have any kind of a substance, it will not boil until its atmospheric pressure and vapor pressure are the same. So the vapor pressure here has to equal the atmospheric pressure in order to boil. That is how we determine what the temperature is going to be at the boiling point. If you have a solution, the solution is going to have a vapor pressure less than the solvent. So this is pure solvent, and this is the solution. At every temperature, the solution is going to have a vapor pressure less than the pure solvent. As a result, you get a new line that shows the vapor pressure of your solution. And as you can see, in order for it to boil, to have its vapor pressure equal to the atmospheric pressure, you have to have a higher temperature. So in order for it to boil, you need to increase the temperature so the vapor pressure increases, so that the vapor pressure and the atmospheric pressure are the same. So boiling occurs when the vapor pressure is equal to the atmospheric pressure, and since the vapor pressure of the solution is less than the pure solvent, boiling point must increase for this to occur. Why is the freezing point of the solution going to be less than the freezing point of the pure compound? We are going to have a line similar to what we had over here, the water vapor and the liquid water, on this side. And once again, in order for melting to occur, we need to go across from the 716 millimeters of mercury, which is standard atmospheric pressure, and we're going to see where the intersections occur. For pure solvent, it's going to occur around 0 degrees Celsius for water to melt or to freeze. But as you can see, since the solid vapor pressure line is less, its freezing point is going to be correspondingly less.